I have here a picture of some copper carbonate. This is a very common substance used in paints and coloring because it's insoluble in water. The water's not gonna wash it away, and it has this nice aquamarine color. It's pretty simple to make. All I need to do is take a soluble copper compound. I could take, let's say, some CuSO4 and add some carbonate to it. So I could do that with some sodium carbonate, Na2CO3. Both of these would be soluble, so let's put our little aqueous in here. And it would make this reaction. I would get CuCO3 plus Na2SO4. Okay? Now this would be a solid, and this would be, and I'm going to run out of room here, but that would be an aqueous solution. So what if I wanted to make a certain amount of copper carbonate? How would I figure out how much of the sodium carbonate and the copper sulfate to use? Because I could start with copper sulfate crystals and sodium carbonate powder. Let's say I needed to make something like 100 kilograms of this. 100 kilograms of copper carbonate. Maybe I'm producing something. How would I know how much of each of these to use? Do I just throw 100 kilograms at this? Oh, no, I don't. Because the thing is, these aren't going to combine according to their grams. They're going to combine according to their moles. This is why we need to learn how to convert from grams to moles and moles to grams. If I wanted to make, for instance, 15 moles of CuCO3, how many moles of sodium carbonate would I need to bring? Well, this equation, this reaction, this is already balanced. These are balanced at a 1 to 1 to 1 ratio. 1 mole of sodium carbonate is going to make 1 mole of CuCO3, so I could just bring 15 moles of this and 15 moles of this. And if I did that, if I brought 15 moles of each of these, I would get 15 moles of copper carbonate. But I can't measure moles. I can't directly measure a mole because that's a number of individual atoms, individual molecules. And I can't count sodium carbonates. They're too tiny, and I can't count a mole of them. That's too large of a number. I can't count that high. So we need a way to figure out how many moles of one of these we have. We already have that. We're able to convert from grams to moles, remember? So if I needed 15 moles of one of these, I would just figure out how many grams that is. So let's try this. Let's try putting this into practice. This is the idea behind stoichiometry, is being able to figure out by weighing one substance, how much of another substance am I going to get? So let's just say, just for the sake of argument, I have 50 grams of copper sulfate. If I wanted to figure out how many grams, so I'm going to go, how many grams of CuCO3 am I going to get out of this? I need to figure out first, how many moles of copper sulfate is that? So let's figure that out. What's the molar mass of copper sulfate? Copper sulfate is going to have a molar mass of 159.6 grams per mole. Okay? And then before I go any further, I'm going to be trying to find the copper carbonate. So I'm going to want to look up the molar mass of that as well. It's going to be 123.55. Great. So these are our molar masses, and that's grams per mole again. So now I want to figure out how many moles of copper sulfate do I have here. So let's put this together. Let's use this color. I'm going to start with 50 grams of copper sulfate, CuSO4. And I'm going to convert that from grams to moles. And my ratio here is going to be 159.6 to 1. So that'll tell me how many moles of CuSO4 that is. That gives me 0.313. So 0.313 moles of CuSO4. So how many moles of copper carbonate is that going to be? Well, I could easily figure this out. This is a 1-to-1 ratio, so it's going to be 0.313. But what if it wasn't? How would I know? Well, we're going to see this in future reactions, but let's just go through the lengthier process now to see what I would do to figure that out. Since I've got 0.313 moles of CuSO4, and I want to go from CuSO4 All right, that's the unit I'm getting rid of. I want to go to CuCO3. Well, I've got a 1-to-1 ratio. So if this was any other number, I could still make this ratio, and then I would just have a simple equation that would tell me I'm going to have 0.313 moles of copper carbonate. Okay, so I've got 0.313 moles of CuCO3. Now I need to know how many grams of CuCO3 is that going to be. So now we're just going to convert back to grams. So I'm going to go 0.313 moles CuSO4, not CuSO4, CuCO3, times, I'm going to go from moles to grams, and that quantity is going to be 123, 123.55 for 1. And what is that going to be? Awesome. So that's how we figured that out. So now I've got 38.7 grams of copper carbonate. All right, we've got another chemical reaction set up here. Let's take a look at this one. Let's say I'm starting with 15 grams of copper, and I want to know how much silver am I going to get out of this? So first off, let's figure out the molar masses for my copper and my silver. I'm not going to need to worry about anything else here because I'm not trying to find anything else here. I've got copper and I've got silver. So my first step is going to be converting the copper from grams to moles. So I've got 15 grams of copper times my molar mass, grams to moles. It's going to be 63.5 over 1. That's going to give me 0.23, what was that? 0.236 moles of copper. Okay, now I need to go from moles of copper to moles of silver. So to do this, I need to convert from copper to silver. So I'm going to put copper at the bottom so that cancels out. I'm going to put silver on top so that I get silver. And so I've got 1 mole of copper in my formula and 2 moles of silver. Okay, great. So then for every 1 copper, I get 2 silvers. So what's this? It's going to be I don't even want to do it. 236 times 2, 0.472. 0.472 moles of silver. All right, now I can take that 0.472 moles of silver, and that's right here. This is 0.472 moles. Now I need to figure out how many grams of silver is that going to be. So I'm going to convert back into grams. So I'm going to put moles on bottom, so that cancels out, and put grams on top. I'm just going to put in my molar mass, 107.87, and I'm going to do that calculation. That gives me 50.9. 50.9 grams of silver. That's my answer. Fantastic. Now let's try one that's a little bit more difficult, a little bit more involved. Okay, I've got a reaction here of aluminum reacting with hydrochloric acid. And the aluminum is going to be oxidized to become aluminum chloride, and I'm going to release some hydrogen gas. Now let's say I want to know, first off, I want to use the hydrogen gas to do some other reactions. It's going to be an ingredient later, so I want to know how much hydrogen gas am I going to get out of this? If I've got, let's say 50 grams of aluminum. Nice and simple. 50 grams of aluminum. How much hydrogen gas am I going to get out of this? How many grams? But then I'm also going to need to dispose of the aluminum chloride, so I need to know how much of that I'm going to make as well. So I'm wondering how many grams of aluminum chloride and how many grams of hydrogen gas am I going to make? So just like we have been doing, our first step is going to be to find our molar masses for everything. All right, so my next step is I need to find the number of moles of aluminum here. So let's put that in red. Let's go 50 grams of aluminum, and I need to get rid of grams, go to moles. So that's going to be 26.92 to 1. So I'm going to take that division. It's 1.86 moles of aluminum. Okay? So now I need to convert that moles to moles of aluminum chloride and moles of hydrogen gas. Let's do that in another color. Let's do that in this orange. So we're going to go 1.86 moles of aluminum. We're going to go from aluminum to aluminum chloride. So we're getting rid of aluminum and we're going to aluminum chloride. And so here we've got 2 moles of aluminum and 2 moles of aluminum chloride. It's nice and easy, that cancels out. So we're going to end up with 1.86 moles of aluminum chloride. Great, let's write that up here. We've got 1.86 moles of aluminum chloride. Now let's figure out the number of moles of hydrogen. Let's move it down a little bit. Let's make some room. Let's do that in pink. So we've got, once again, 1.86 moles of aluminum times, get rid of aluminum so I can go to hydrogen. I've got 2 moles of aluminum for every 3 moles of hydrogen. That's what these numbers mean. That's what these numbers here really mean. When we balance those reactions, figuring out what's our ratio for stoichiometry. Okay, so now we just need to take this. So 1.86 times 3 divided by 2. We get 2.79. So let's write that up here. That's 2.79 moles of hydrogen gas. Okay, so now I just need to convert these moles into grams. So let's figure that out. Let's do another color. First let's make a little division here. These were all my molar calculations. And now here, let's do this in, let's do a little green. So let's take our 1.86 moles of aluminum chloride. Let's convert that from moles to grams. That's going to be 133.34. Let's take out our calculator. Okay, so now let's put that here. We're going to have 248 grams. So that's one of our answers. Now we just need our other answer. Now we need to go with the hydrogen. So we've got 2.79 moles of H2. Now we need to convert from moles to grams. So for every 1 mole, we have 2 grams. Okay? That's just 2.79 times 2. It's 5.58. And there we go. So this one is 5.58 grams of hydrogen gas. So there's our answer. So we should be able to walk away from this video being able to do this fairly lengthy process of figuring out from grams of a reactant, determining how many grams of products are we going to make. So we need to convert from grams to moles and then figure out how many moles of products that is going to make and then convert from moles back to grams. So it can be a fairly lengthy process to do stoichiometry, but once you get used to it, it really becomes pretty streamlined.